Right, the final video for this chapter is going to be looking at using or solving trig equations like the previous video, but then using some trig identities to manipulate it first in order for us to solve it. So an example of this would be maybe tan squared theta is equal to 2 tan theta, and theta is between 0 and 360 degrees. Okay, so we're trying to essentially find theta again, like the previous video. But before we do that, we need to change it up or manipulate it a bit. So as you said, we want to make it only into one term, right? Or in each case, right? So we want to move it all to one side. So I'm going to say tan squared theta minus 2 tan theta is equal to 0. Note, in the initial part here, you might think, oh, it's squared and tan, so I can cancel out and cancel one of these squares. We never want to cancel out when dealing with trig terms like this, because we will lose solutions. So instead of cancelling, what I'm going to do is I'm going to be factorizing instead. Okay, so that's a very important note to be aware of. So as I said, we're not going to cancel, we're going to factorize. So now I can take tan theta out, and we'll have tan theta minus 2 like this is equal to 0. Which means that tan theta is equal to 0 and tan theta minus 2 is also equal to 0. If we had simplified in the beginning, we would not get this solution here, we would miss out on these solutions here. So that's why we don't cancel out in the very beginning. Right, so from here though, we just now use a calculator to do inverse tan. So theta we get 0, tan theta is 2, so inverse tan of that, you should get 63.34 degrees. Now it's the same method, we draw the cast diagram for each one. So for the tan theta is 0 and tan theta is 2. So for 0, it's a positive value, so CAST is going to lie here because it's 0 degrees, and it's also going to lie here because it's also 0 degrees. For this equal to 2, 1, it's going to be the A section, 63.4 degrees, and in this T section, 63.4 degrees. So now it's just a matter of finding all the solutions. So theta for the first one will be 0 degrees, and then here will be 180. For this second one, the theta will be 0 plus 63.4 and 180 plus 63.4 degrees. So all the solutions will be 0, 180, 63.4 and 243.4 degrees. So we have to make sure that we get every single solution possible. Let's try another one. So let's try maybe 4 cos squared theta minus 5 sine theta minus 5. Right, so as I said, we might have to use an identity that we've learned, right? So we want to change it all into one trig term, right? So we have a cos squared and a sine. So it's best if we change it into sine if possible. And we know we can do that because we have cos squared theta plus sine squared theta was 1, the identity we've learned in the previous video. So I can replace this for cos squared theta with 1 minus sine squared theta, can't I? Minus 5 sine theta minus 5 is 0. Now a bit of expanding and simplifying. So we get 4 sine squared theta minus 5 sine theta minus 5 is 0. Let's move it all to one side. So 4 sine squared theta plus 5 sine theta plus 1 is equal to 0. And as you can see now, it's all in terms of sine or sine squared, but now we can actually factorize, which is similar to a quadratic equation form. So what we're going to do is we have 4 sine theta here, sine theta, we have plus 1 and plus 1 like this. That way we can factorize it, meaning that this term is equal to 0 and this term is also equal to 0. So that we'll get sine theta is equal to negative 1 over 4, or sine theta is equal to negative 1 like this. Using the calculator, you should get your theta value. So theta comes up to negative 14.5 for this one, and theta becomes minus 90 degrees for this one. We now draw a cast diagram separately, so one for each one. So CAST, this one is a negative value here, right? So we draw in the T section and C section, 14.5 and 14.5. CAST again, this one is also negative, so it's going to draw 90 degrees, but it's going to be 90 degrees because that's in the middle, right? So we only have to draw one line for this one here. Now it's just a matter of finding thetas. So for here we have 180 plus 14.5 and 360 minus 14.5. And this second one will only get 270 degrees like this. So all the solutions we'll get is 194.5, 345.5 and 270 degrees. We get 3 solutions for this particular example. Let's maybe try one more. So let's try 2 cos squared x plus cos x minus 6 is equal to 0. Once again, it's in a quadratic form, so we can factorize. So 2 cos x and cos x, and we'll get minus 3 here and plus 2 like this is equal to 0. So therefore cos x is equal to 3 over 2, or cos x is equal to negative 2. Now we would put in the calculator to try and find the x values. But if you put in the calculator in this case, for both scenarios, you actually get an error. And that means that there's no solutions to this particular example. The reason being is if I drew the cos graph, right? So cos x will look something like this. We know that the maximum and minimums are 1 and minus 1. But this is asking us for when cos x is 3 over 2, i.e. when it's roughly around here. And as you can see, it doesn't intersect at all because it can't be 3 over 2 because the maximum is 1. Same thing for minus 2, right? They're asking us when would it intersect if it's minus 2 here, right? And once again, it can't intersect because the minimum will be minus 1. So for this example, there's actually no solutions for this particular equation. So that's the end of the trig chapters. Maybe it's best just to practice a lot of questions, again, used to all different types of questions, and just being aware of the identities and just being very comfortable with using the class diagram and finding all the answers to the solutions.